Alrighty. Hope everyone can hear me okay. Welcome to Amsterdam, and welcome to this talk as well, and go behind the scenes with Space Invaders, the World Defense Team. Really excited to talk to you today about our latest release on the world scale with an augmented reality game built in Unity. So just to go over introductions, this is a really old picture, so don't mind me if I look a little bit different. My name is Dereck Bridié. I work as a developer relations engineer over at Google, working with ARCore and really helping to get augmented reality technology with everybody who's interested in it, and promote our augmented reality stack as well. And today I'm joined by Jakub Jakubowski, a creative director at Unit 9, great friend who really helped put this vision of ours into reality. Let's see here. Space Invaders, we all know it. It's a super iconic IP. It's been there for more years than I've been around, so it's been such an honor to work with this legendary IP. This is definitely something that we wanted to bring to the next dimension and the next level as well. This was a collaboration between the Japanese company TAITO, who published the original Space Invaders game, along with Google, of course, and the Unit 9 production team as well. And with that, I'm going to leave it over to you for telling everybody about the awesome game design.
Hello, everybody. I'm Jakub. I'm a creative director at Unit 9. Thank you, Dereck. And I'm going to take you through a little bit of the creative thinking behind Space Invaders World Defense. So as many great products, this one also started with a big idea. What if we have Space Invaders in reality? This idea came from the head of creative innovation at Google, Matthew Lorraine, created this quick mock-up that represented how this could actually play out, and then got in touch with Unit 9. So enter Unit 9. We come back with something with a little bit more emotion, a little bit more advanced and fleshed out, and this is how it pretty much turned out in the very end. So one quick idea, we take it to the next level with something that is actually possible, doable, and how it's going to end up in the very, very end. So starting with these little basic items, we had to sit down, we have to think, why did we build this game? So starting with the Space Invaders franchise, we wanted to bring in the big classic into 2023, into the modern times, which was a challenge in itself. We wanted to do that by showcasing Google's latest technology, and not just one specific feature. We wanted to showcase a whole stack of different technologies that came together to form the gameplay. And we also wanted to do this to inspire young developers, creators, to build something of a similar stack within their own projects. So before we jump into the actual gameplay, we have to just face the elephant in the room. We were making the next Space Invaders. So the game is also older than me, not only Dereck, and I guess most of us here. Space Invaders is a legend. It's an icon of the arcade generation, and we had a giant task at hand to make it work with modern tech in modern times. So we opted for a more advanced approach. When we were designing the game, we were thinking AR, streetscape geometry, geospatial tracking. How does that marry with the classic Space Invaders gameplay? So we took a step forward. We took the game to another level by splitting the gameplay in half. First part, the turret AR gameplay is strictly AR when you point and shoot against the incoming invaders. That part plays more homage to the original, where the invaders attack you and you play the defense. But actually, the next step is that we go into the invader dimension and get some sweet, sweet revenge on the aliens. So we wanted to do that in a flashy way. We wanted to make that a wow moment. And with the use of streetscape geometry, we could pull something like that off. So when you play the game, this is a cycle. You start with AR, then you transition into the invader dimension, then you go back to reality, and the cycle continues as long as you can keep the onslaught going. It also helps a lot with something that was internally called gorilla arms. So playing AR for a prolonged time, you just get tired. So the screen space is played, the invader dimension is played entirely in screen space, so you get some time to rest your arms and get ready to jump back into action when you go back to reality. So the AR turret mode. Here, initially right off the bat, the idea hit us. It needs to be simple, pick up and play, Space Invaders classic homage. So you point and shoot. But we developed the gameplay a little bit further. We added tracking of the crosshair with your finger. We added tracking with gyroscope and accelerometer, as well as a couple of upgrades, power-ups. The biggest challenge we initially faced is that when giant voxel monsters come approaching you, you try to dodge. But we had to prevent that to prevent people from falling on their cars, especially when the game is played in such a busy place like Tokyo. So we had to introduce a little bit of safety to it. So the game is meant to be played in a full stationary position. As for the invaders actually moving, we took inspiration from the classics. So they still have that step-by-step movement. They encroach on you in mass. As you play the game, there's more and more of them. So the progression really takes it from a very simple look around and shoot to a hectic defense of an army invading. Of course, we couldn't live without a classic high score. So we once again looked at the originals, saw what worked, and everybody who has played any arcade game can recognize just 3 letters, and that's it. There are no logins. It's just pick up, play, have your 3 letters up in the local leaderboard, and get your shellerbow to take away. The game is played in a score attack mode. So you play as long as you possibly can, fend off more intense waves of these invaders, and as high as you can get, that's where you actually land. Further development of the game took us to create local leaderboards. So there are high score leaderboards that are localized to certain areas, so you can be your local champion. And of course, the customizable shareable reflects all your scoring, your locations, and your date, so you can have that tangible proof that you were #1 in your district. Fun fact, this is our designer. Once we started to work on the project, we had a lot of discussions with Google, with the TAITO team especially. What sort of creative freedom do we have here? What we can change, what we can develop on our own, and how strongly they want us to adhere to the original style. Thankfully, the TAITO team was very trusting, and they allowed us to push the art direction and gameplay quite significantly. So as you can see, we opted for wireframe, neon-like visuals that immediately build that connection to this retro gaming style. Of course, accompanied with sound design that takes us back to the retro era. But we also wanted to give it a little shine, a little push to emphasize that this is a modern game. So within UI and the overall color palette, as you can see, we are quite in the future, but what was the coolest thing we did is actually working on the invaders themselves. These guys are legendary. They are very, very restrictive with any modifications. So basically, the shapes are holy. You cannot change a single pixel in these, and that includes movement and animation as well. However, what we could change was the skinning. So we created these awesome patterns that work together with the classic Space Invader shapes to create something completely new, something that fits our game and makes each invader unique and special. We also coupled it with some visuals for power-ups. Here we have the famous cat gun, which unfortunately didn't make it to the game, but we were still using the icon throughout the entire production. and the invaders, they are all created procedurally. So we have a lot of different combinations, a lot of different color pairings, which also translate to different power-ups and guns you can have and play with during the game. A little bit of motion, well, we can't change the pixels, we can't change the shapes, but we can add stuff on top. So we have our power-ups being signified by these rotating cubes, and we add a little barrier to make the game a little bit harder in the later levels. When the invaders are attacking, of course, they can't appear out of thin air. They need a nice, tangible way to come in, to actually get inside our world. So we have designed these portals and a special algorithm that detects a nice surface from which they can spawn into. So it's created, we created a system that always showcases the action. So where you actually are looking at, that's where the system recognizes a surface, it spawns a portal for an invader to come in. It was quite a challenge because we had to accommodate for busy areas like the center of Tokyo, but of course the competition is global, so it works in the desert as well. A little bit of motion, once again, we go back to the classic retro kind of feel. When it all moves together, even these simple wireframe graphics and neon colors playing together create this cyber experience. But the creative direction, the creative freedom did not end there. We also had additions that we created. Power-ups and the combo system, they enhance the gameplay. They make it a little bit more momentum-based. So you are always on top of the action, always looking for the next target and for the next power-up to give you a very powerful weapon. We have a procedural power-up generation system in place as well, so there are dozens of different weapons you can actually try out. And here's a couple of examples of those. Each weapon has a different projectile. Thanks to the Unity particle system, we could actually create quite a few with a lot of variants and different effects that accompany these projectiles. And that takes us to the invader dimension. So here is where we jump into that other dimension, that other world where these space invaders actually dwell and come from. So here we transition using the Google Streetscape, all the buildings you can see here. This is actual geometry. We take these models and we reskin it entirely to make up a new world for the players to explore. And the player actually does explore that world without moving from his starter spot. We take off, we shift the perspective, and we start flying. So as you can see here, you have finished the level in the spot, the ship flies into the portal, and we take over the entire screen. At the same time, our ship links to the screen, and we take off and fly through the geometry. So if you play that in your neighborhood, I'm sure that once you start flying around, you're going to recognize, like, this is the parking lot where I leave my car, this is my shop where I do my groceries. It's a really strange feeling when you play a game such as this within actual reality boundaries that surround you. But it's, I think, the next step and a great playground to explore with further projects. The transition had to be seamless. We had to weave it in so there is no jarring, jump from one gameplay to the other. So all the controls are the same. The player doesn't really need to do anything. Everything is automatic and smooth. But we couldn't leave it like that. We also had to add a little bit more of the procedural generation to the entire Space Invaders world, so it reacts to the current weather conditions and time of day. It changes according to temperature, to weather forecasts, so wherever you play your Space Invaders World Defense, you're gonna encounter different levels. And this whole system ends and cycles at the very end of the Space Invader dimension level, where you fly through this geometry. You shoot up the maximum possible combo you can get. Of course, in this world, the invaders are much more aggressive. There's more of them. because it's their hometown, but nevertheless, you go there to annihilate it. And you reach the end of the level, you fly back into reality, and the cycle begins again. So high scores are attained by players who shoot fast, have good aim, rack up those combos, collect all these power-ups, and do it all over again as much as they possibly can hold out. This concludes my section, so it's been a pleasure, and I'll be handing back to Dereck.
Yeah, thanks. Love to talk to you today about all the technology that makes all this possible. Let's say the first layer of this cake is ARCore, which is really Google's augmented reality SDK for developing smartphone AR experiences. So we support ARCore on multiple platforms, in this case being Android, iOS, Unity, and web. And it really provides the AR fundamentals that you need to create an augmented reality app, like world understanding and motion tracking and that kind of stuff. And of course, we wouldn't be here if we didn't love Unity. So we're here, really spreading our love for the first-party support as well. You may have seen it in the keynote, Unity's AR Foundation, which really offers the same kind of write once and deploy everywhere experience that you're used to from Unity, where you can create one augmented reality experience and then kind of deploy it to an iOS target device or an Android target device. And Google also provides, I call it the Google secret sauce through ARCore extensions for AR Foundation, where we add some incremental features onto AR Foundation. And one of the important ones being, what we've been talking about this whole time, ARCore Geospatial API. And the Geospatial API is really the foundation of the technology stack that we use to make the Space Invaders game. So we use the camera feed to accurately position the player. And while you do that, you hold up your smartphone and you kind of scan the environment around you. And we use that data and compare it to the Street View data known in Google Maps. So we kind of get the feature points from everything, and the algorithm determines, where do you think we are compared to the Street View data that has already been recorded by us. And that can give you really great precision, especially in areas where GPS isn't so great. And it kind of solves this problem in Google Maps, where you're looking at Google Maps and you're like, well, am I pointing this way? Am I pointing this way? No. We know which way you're pointing because your camera is directed at a building, and we know where that building is. And so therefore, we can kind of determine where you are relative to that building as well. And it's available in over 100 countries, so it's really like a global experience that you can get from using this technology as well. And we've seen the Geospatial API used in a lot of different use cases as well. So we've seen it in commerce. On the left, you can see like a Gap and Barbie Mattel experience being created. We've seen it in arts and culture as well, and tourism, and even in urban planning as well. So we're super excited about the Geospatial API and hope to see it used in even more places as well. And in this case, we really wanted to explore the opportunity of combining the Geospatial API with gaming. So as I mentioned before, we need you to scan the environment around you to determine that VPS location as well. So in this game, we kind of instruct the user to do that by having them follow the ship, and the ship will sort of pan around you as well, and that creates the effect of the VPS scanning. So trying to get like the technical requirement of having the environment scanned combined with the storytelling aspect of it as well. So that's one of the things that we really got out of this as well. And of course, Jakub described it already. We wanted to really make the world around you the playground. So your player environment will be reflected in the invader dimension, and as mentioned before, you'll be able to identify some buildings that are around you as you fly over them and fly near them as well. So as mentioned before, the streetscape geometry integrates real buildings into your gameplay, so you can sort of see here as well. This is our understanding of the 3D mesh of some of the buildings. I think this is a street in Tokyo that I've chosen. And you can see that the 3D mesh really tries to accurately map the real-life depiction of the building as you would understand it. And this is the kind of data that you would be getting from the Geospatial API as well. So looking forward to see what can be done with that as well. But we all live somewhere else. The real world is really diverse. Some of us live in metropolitan areas, maybe some not very dense urban areas as well. And this is where I think the power of Unity really came out and showed itself to us as well, because we were able to import like different types of scenarios where dense urban areas or anything else like that into Unity, and kind of test and preview the algorithms used in the Unity editor and kind of like evaluate them. Do we need to tweak something, or is it just fine the way it is? And I think the Unity editor really helped us iterate on solutions and come up with the best strategy here. So here you can see one of our developers testing where the portals could be placed that Jakub showed earlier. Another thing that was really great, we've all encountered this problem before, it's pathfinding. So I think this version of pathfinding I haven't really seen earlier before. As the spaceship flies around the invader dimension as well, it finds an interesting path according to our criteria. And that's done by generating a depth texture from looking at the buildings from the top view and then looking down, and analyzing which kind of direction would the spaceship fly through to sort of get an interesting path and not like a boring circle or anything like that. So we use this depth texture to generate a pathfinding grid and try to plot a course that finds some different points in the grid and maps it back to 3D, so you can get the height difference back and fly over buildings as well. And then, of course, we try to smooth out some of the irregularities and the sharp turns as well, so it's more of a smooth experience flying over your town or city. And then on the left, you can see the Unity preview as well. So I think I want to hammer home again, we loved Unity for this because it was able to show us all of the intermediate steps as well as the final result as well with the pathfinding. And on the right, our results. All right. I also want to plug Geospatial Creator. If you've ever used Google Earth, you may have seen something like this before. So an easy way to get started with augmented reality and the Geospatial API is with Geospatial Creator, and it's all in the Unity editor as well. So this uses the photorealistic 3D tiles API to really show you a real-world environment directly in the Unity editor. And what you can do in this is anchor an asset to, let's say, the top of the Tokyo Tower, and anchor it in the Unity editor, and then go out, build your app. Well, I guess you would have to fly up to the top of the Tokyo Tower, but you would be able to see the asset in augmented reality using this preview. And it's all in Unity. If you want to check it out, search for Geospatial Creator. And of course, Google Cloud. We really aim to have a high amount of users distributed all around the world. So it was really essential that we had a robust scaling service that could handle all of the leaderboards as well. So they were hosted all on Google Cloud, and we were able to sustain a large burst of initial players using Cloud Run and the memory store scaling. So yeah, really excited about that as well. And then, of course, I think you've heard it all in the keynote before. Launch day, it might only be half of the developer or your developer journey as well. But the second half, sometimes more interesting, sometimes more difficult. But I wanted to go over what we learned from that as well, and what we think will go better next time. So the first thing is, we've talked all about this Geospatial API, but that really requires that you go outside. And what we've learned from this experience is that clear messaging really starts before the install button is pressed. So, be it in the store description or in any other types of marketing materials your user may have seen before pressing the install button, it needs to be clear that the experience was to be played outside. This kind of was reflected in the title screen where we said play outside instead of to start game, and the loading screen, which will try to nudge you in that direction as well. But in the end, I think, when you're downloading a game, maybe you're already sitting on your couch or you're at your desk or something like that, and it's kind of like a hard sell to get somebody to go outside after all of that. So after the initial feedback, we added indoor mode so we could meet users where they were at and have them fly over preloaded cityscapes. And that also had the additional benefit of removing friction in permissions dialogues. Because we had to use the camera feed to get people to geolocate and stuff like that and ask for GPS permissions as well. So it had some added bonuses there. What went well? I think what went well for me is that I got a perfect little shareable for my location in Den Haag. And we have also seen way more interest in other brands for collaboration using the Geospatial API. Yeah, I think that was one of our main goals on the Google side, is really to get increased awareness of augmented reality gaming and really gain some more market validation of the geospatial technology. And I think Unity was really integral to how we were able to ship this because, of course, our timeline was very condensed and we had a lot to do and ambitious goals. So I think the Unity editor really helped us get going and iterate. And if we had an idea that we didn't like so much, we could quickly pivot and go in a different direction as well. All right, that concludes our talk on Space Invaders. We'll be taking questions for a little bit if anybody has some. Thank you.